Welcome friends to Power Plant Guru YouTube channel. Friends, I am a mechanical engineer with around 20 years of experience in the field of power plant, and I used to create small fundamental knowledge series videos for power plant engineers. We also run doubt clearing sessions on weekends. So if you want to reach us, you can reach us through comment section and join our weekend classes. Let us continue to watch our today's video. So friend, let us understand pre-startup checks in gas turbine. So pre-startup means before startup you need to check all these things. Otherwise your machine will not be starting showing any interlock which may inhibit the start command. So let us understand what are the pre-startup checks you should do. And more importantly, why these checks are required. Not only what, but why. So first one is fire protection. So it is very evident that there should not be any fire or that kind of incident in the machine when you are starting. So this point is very valid. There should not be any fire alarm. Next one is C means there are CO2 suppression, fire suppression system where CO2 is flooded in the compartment to suppress the fire. But there are mechanism where you can lock your CO2. There will be a small valve which you can change the position. You can close that valve and for each compartment, and then there will be a limit switch. If the CO2 is on, the limit switch is getting touched, and you are getting that signal, okay, CO2 is not isolated. But when you change the lever position to this side, this limit switch is not engaged and machine is knowing you have locked any compartment CO2 for maybe reading taking or any inspection while operator is going inside the compartment. So that is this thing. CO2 should not be locked in any compartment. All compartment CO2 suppression system must be active, and that limit switch for that should be there in the signal. And another thing is CO2 released alarm. So there should not be any case where your any compartment CO2 cylinders or CO2 bank shows that there is already a discharge happened. Maybe it may be a false signal also, but you need to check that there should not be any this kind of signal where CO2 is already exhausted, or maybe from last shutdown or last event wherever machine tripped, there may be a CO2 flooding condition in the compartment. So that should be also refilled and made healthy. So these are three protection related to fire system, and there should not be any alarm. All CO2 compartment system should be ready, and there should not be any CO2 system, any zone which is not having CO2 system active. So this is on fire. The next is machine speed. The machines should at the 14 HM level, and the limit switch should be on starter fuel side. So 14 HM, many people may understand or many may not. So there are 14 HR, 14 HM, 14 HA, and 14 HS. So this system, these are stages of speed. So R says resting, M says minimum, A says acceleration, or S said ready for sync. So these are four type of speed signal pickups, and 14 stands for the speed signal, ASME speed signal coding, and H stands for high pressure shaft. So HM means it is at a minimum speed, which may be ratchet or which may be barring for different machine. And this is rest, so it should be more than rest and less than acceleration. So it has to be on HM. So this is that point. Next point is it should be on starter fuel. So people who are aware or maybe well versed with primary or secondary fuel, maybe your machine is able to let's say HSD and naphtha. Then there will be a three-way valve. Fuel selection, there will be a three-way valve uh, like this. Excuse me for my poor drawing. With that mouse I cannot write much better than this. So it should be on this side, HSD side. It should not be on this side, so that your machine is knowing, okay, my this thing, I'll whatever fuel will go, that will be only startup fuel, and the next after the startup is there, then I can switch to the this base fuel. And why HSD, why naphtha is not startup fuel, I will take another video to explain why different kind of fuels are selected for startup only and not for this thing. So this point also we are covering. 14 HM I have explained, and startup fuel also. The third point is on variant pump lube or skid, there is no trouble. So there is a variant pump which supplies fuel to the machine. It takes fuel inlet from your off-base fuel oil pump and then pressurize it and supply it to the gas turbine. But for this variant pump, there are a separate lube ball skid. A separate lube ball skid is there for variant pump, where there is an AC pump and a DC pump is there. So the common discharge line will come from this and go to the bearing of this your variant pump. And why variant pump has a separate lube ball system, that is also one very good topic. Let me take a session on variant pump and explain this. So first we are discussing here variant pump lube ball skid. So maybe people maybe known this system by John Crane. John Crane is the manufacturer of this skid in some of the machine. So John Crane system, there should not be low pressure alarm or high filter delta P alarm or pressure switch. This kind of alarm is not there, so that whenever you are starting your machine, it will come on HSD. Then HSD should have your healthy variant pump system, so its lube ball system should be healthy. So that is from where it is coming. So next one is atomizing air pressure measurement. So it should not be greater than 5 psi before HM. So it is very normal that it should not be 5 psi, but this is to check that your atomizing air pressure is getting very accurately measured. There is no error in measurement of your atomizing air pressure, so that is why this check is there. And another is lube ball temperature should be normal. So your lube ball temperature should be greater than 55. Mainly this one in colder countries you may have problem with oil getting very low temperature, so that should be one check here. And another check is there, like you have your machine was stopped due to lube oil temperature high, and now what is the temperature, whether it is retained the normal temperature system or not. So that is why this check is there. And the next one is there for checking the flame scanner healthiness. So while you are starting, there should not be any flame, no flame technically when you are starting your machine. But if there is any flame is getting sensed by your scanner, that means there is some problem with your flame scanner. So all that flame scanner are reading zero intensity or no flame. That is one check which is essential. That is why this also getting checked in pre-startup. And this 14 HM I already explained that your machine should be the speed level pickup should be 14 HM, which is more than 14 HR and less than 14 HA. Here, all the doors of accessory compartment, turbine compartment, and if you have your DLN system also, then should be closed. Why this should be closed? Because in case of any, this is related to safety that people should not be accessing machine compartment when it is in acceleration or startup. Basically, the hazard is release of CO2. So in case of any fire or any this type of event, the CO2 may flood into the system. So that is why the door should be closed and the person operator should be out from the turbine compartment. That is one check which has to be there in the startup system. So the next point is your liquid fuel supply trouble should not be there. And this signal comes from your DCS, wherein your fuel oil pump house or fuel forwarding skid are there. From there, the liquid fuel pump have sufficient pressure, and there are no this thing delta P across your suction strainer or filter. There should be pump. There should not be any alarm in pump bearing or something. So that all logic is written in DCS, and from DCS this input comes to your Mark 6 or Mark 5, whatever system you have, so that the fuel oil which are going to run the gas turbine, that system is healthy. That is one check. The next check is fuel shutoff valve. The fuel shutoff valve, this is basically trip valve or stop valve. So if you are going to start your machine, that means before startup, the stop valve definitely has to be closed. So that is just check that when you are starting your machine, before that there should not be any stop valve open condition which might have lead to fuel accumulation inside your machine before startup. So that is a check to reduce the safety, to reduce the unsafe condition which may happen in the startup system. And then this is emergency oil. So why emergency oil? Before startup, you need to check that if my machine trips or if my machine goes for a shutdown due to any reason, then there should not be any trouble with emergency oil pump. So before starting the machine, I will check that my emergency oil pump system is healthy or not. So from there, the MCC, this signal should come and tell that Mark 6 that okay, the emergency oil pump system voltage and everything is fine, and then you should start the machine. The next one is IGB position. So yeah, IGB position, you know that the minimum, whatever is minimum, maybe 34 degrees C, 34 degrees C or whatever is there at that machine particularly. So it should be on the minimum position, so that whenever you start your machine, there should not be much air, very high quantity of air should be going to your machine. and you need your IGB to be minimum position to make your flame and everything sustainable, and it's your startup sequence to go forward. So that is why the IGB position has to be minimum. And then there are bleed valves, there are two bleed valves in some machine, smaller capacity, and there are four bleed valves in large capacity machine. So all those machine bleed valves should be open to avoid two situation basically. One is your surging of the machine, another is your very high quantity of air which is not required at the startup conditions. So that is why your bleed valve open position limit switch should be active. And then this is a master protective signal, which all you may be knowing, that the overall control system L4 master protective relay is active, so that in case of any unwanted event or any unsafe condition, there has to be active mechanism where the false can be triggered, and then it should be generated for a shutdown. And this compressor discharge pressure, which is very similar to what we have discussed for atomizing or air pressure, there should be your check that there should not be any false alarm or any faulty readings which will be fed into the system. So that is why before startup, this compressor discharge pressure fault alarm system is noted. And the next one is there then the vibration. So there are different groups for vibration, turbine or generator and other things. So there should not be any sensor which is inhibit. Inhibit means, let's say you are running your machine and you see there are 5 sensors, and out of those 5 sensors there is one sensor which is in alarm state or showing a lot of vibration. So people inhibit that, or we can say force that to healthy. Sometimes they do force it to healthy, or sometimes they inhibit. Inhibit means this will not go into the control system or any activity for taking decision. So that sort of inhibition should not be there in any of the vibration groups. And the next one is which is coming from your electrical system, that there should not be any trip coming from any 86 series relays, which is any of the trip relay. And then your all three processor RST processor should be okay, and there should not be any IO state trouble or alarm from that side. Next one is very trivial, that if you are selecting which fuel based on if you are selecting gas fuel, there should not be any fault in gas control scheme, GCV, SRV, or any pressure related thing. Or if you are selecting liquid fuel, then there should not be any fault on liquid fuel side. So these are basic startup checks, and why we should do those startup checks before thinking of starting gas turbine. That is what we tried to explain in this video. There may be many questions on this, because if you dig down deeper in details, you may find many conceptual doubts. So I would recommend you to ask those questions in the comment section, and I'll try to respond to that questions. Thank you very much.